Alright everyone, so today we're going to be doing a lesson on 6.3, which is solving radical equations. So we did a lesson 6.2 on simplifying radical expressions. So this is going to be implementing those rules in the form of an equation. So go ahead and read through the key vocabulary. An extraneous solution is when you end up with a solution that doesn't truly satisfy the equation. So that's why it's so important that when we solve these, that we plug our answers back into the equation to verify them. So we have to isolate the radical on one side if there's only one radical. Sometimes that's not possible when you have more than one radical. So once you get to that point, you're going to raise it to the power. And when we say the power, if it's a square root to the second power, if it's a cube root to the third power, and so on. You're going to solve for the variable and then check for extraneous solutions. So step one is going to be, in this case, we only have one radical expression in the equation, so we're going to isolate it. So we end up with the square root of 3x plus 4 is equal to 5. And then from here, I know that this has an implied index of 2. So I know that if I put it to the second power, it's going to cancel out the root, which leaves me with only what's inside the square root, and then 5 squared, which is 25. Now from here, I can subtract 4 and solve, and I get 3x equals 21, which means x equals 7. Now I have to, before I can confirm that this is a solution or an extraneous solution, I have to verify that. So I have to plug it back into the original equation. Now you might be thinking, that's not the original equation. That's the equation that you manipulated to get into the form where the radical expression is isolated. But I just want to verify with you that that's okay. You can plug it into the true original, or you can plug it into the version of it that you manipulated. Move things around. It's still the original equation because I can still get it back to the other version. Okay. So from here, I'm going to go ahead and plug in my 7. Now the reason I would use this version over the other is because it's just already in a form that's going to be a little easier to plug into. But either one will work. You can always try it out on your own. This is a true solution, so don't forget to put it in your curly brackets, and that'll be the answer. We don't have any extraneous solutions here. All right, so for the next one, same first step. You're going to isolate the single radical expression in the equation. We're going to square both sides. We end up with 4x plus 1 is equal to 25. We subtract 1 on both sides. We get 24, we get x equals 6. Now we have to check it by plugging it back in. We get the square root of 25, which is in fact 5. Sorry, my dog is growling in the background. You might hear him. Just ignore it. Wilbur, calm down. Sorry. Okay. So this one here, we're going to add the 5 over. We're going to end up with the square root of x plus 7 is equal to x plus 5. And now we're going to square both sides. So the radical part goes away, and we're left with x plus 7 equals. Now remember, we also have to square the other side. Now here is a little bit of a dilemma here. If I'm squaring this is a binomial. When I square a binomial, I have to use FOIL or box method. If you'd like to use box method, that'll also work here. First, outer, inner, and last. Combine like terms. And when you get to a situation like this, you have an x squared and an x. You want to get everything to one side because that means you're going to have to factor it. And you can only properly factor in a way that would solve the equation if you can get it equal to 0 using the zero product property. And now I'm looking for factors of 18 that add up to 9, which would be 3 and 6, x equals -3, and x equals -6. So before we can confirm the solutions, we have to plug them both back into the equation. Either version is fine. Replace the x with -3 in the first version. So that's going to be the square root of 4 is equal to 2. That's true. So we know that one of the solutions is -3. Now we're going to do the same thing with the -6. Plug it into the equation. So this is the square root of 1 is equal to -1. So the square root of 1 is 1, not -1. So that's an extraneous solution. I can't draw good squigglies on here. So -6 is not a true solution because it gives us a false statement at the end of the equation when we plug it back in. So we only had 1. So that's page number 1. All right, next page. So B is going to be the same idea. We're going to start by subtracting 3 on both sides. In order to get rid of a square root, you have to square both sides. In order to square a binomial, you have to write it twice and distribute each term out. That gives you x squared minus 3x minus 3x plus 9. Combine like terms, and then since I have an x squared and an x, the only way to solve this would be to use factoring. And in order to factor to find a solution, you need the equation to be equal to 0, because then you can use the zero product property. Then we're looking for two numbers that will multiply to give you a positive 10, but will add up to a negative 11. So that would have to be -10 and -1. And if I set those equal to 0 and solve for each one, I would get x equals 10 and x equals 1 as my possible solutions. In order to confirm that those are actually real solutions, I have to plug them back into the original equation. That gives me 15 minus 1 equals 7. So the square root of 14 is not equal to 7. So, oh, well, that's not 15. That's 50. I was adding. So 50 minus 1 equals, so that would be the square root of 49 is equal to 7. So that is a solution. So we can confirm that 10 is a solution. Now we have to do the same procedure to check for 1. So I get 5 minus 1 equals -2. That's the square root of 4 equals -2. That's 2 is equal to -2. That's false. So that is an extraneous solution. So for the next one, as you can see, there are 2 square roots here. So you have a few different options on how to deal with this. You can try to get each separate square root to opposite sides. So I'm going to start by adding the root x to the other side. I get the square root of 12, or x minus 12 is equal to the square root of x plus 2. And now I can square both sides. That gives me x minus 12 is equal to, and in order to multiply this out, I'm going to need to FOIL it. That gives me x minus 12 is equal to square root of x times square root of x is x, plus 2 radical x plus 2 radical x plus 4. That gives me x minus 12 is equal to x plus 4 root x plus 4. And then we need to try to get everything to one side or see what we can cancel out. If I subtract x on both sides, the x's actually go away, and then I'm left with negative 12 is equal to 4 root x plus 4. I'm going to subtract 4 on both sides. That gives me negative 16 is equal to 4 root x. Divide both sides by 4, and I get negative 4 is equal to the square root of x. Now, technically, I could finish solving this by squaring both sides, and I would get 16 is equal to x. But I already know right away that this is an extraneous solution, and that's because when I'm right at this prime step right here, it says negative 4 is equal to the square root of x. Well, the only way that I'm going to be able to take the square root of a number and get a negative is if we're talking about imaginary numbers. It's not possible to take the square root of a number and get a negative 4. If it would be possible if it was negative 4i, but there's no imaginary indicator there, so for that reason, we can see there is no actual solution. And if you don't believe me, you can go ahead and plug 16 back in. You would get 4 equals negative 4, which is extraneous. So for this one here, the radicals are already on opposite sides of the equation, so step 1 is going to be to put them to the second power to get rid of their roots. And then this one's pretty simple. Get x to one side, get the numbers to the other side, add 7 over, and you get x equals 9. Now to confirm this solution, we're going to go ahead and plug 9 back into the equation. We get 18 minus 7, which is 9, is equal to the square root of 11. So as you can see, this is not a true solution. So that would be extraneous. I'm just going back and double checking this one. Yeah. Alright, so that's the whole thing. Make sure you finish the homework. This one's pretty easy. And I'll see you all after break.